Testing, testing, 1, 2, 3. Can you hear me?
Yes, ma'am.
All right. Let's get it done. Oh, there it is. Okay, mommy will look when I'm done with this class, okay? Let me know when you can see my screen. We okay? Do y'all see it yet?
Yes,
Hello?
ma'am.
Oh, okay. Sure. Okay, let's get started. So I think we left off on me doing example 4 on page 133, which is the application problem for hyperbolas. That's correct? Okay. Okay, so here we go. So it says navigation. In the figure below, the Lorentz stations at A and B are 500 miles apart. And the ship at P receives stations A signal 2,640 microseconds before it receives the signal from station B, which is understandable because it's closer, right? So you have this picture. You don't have to look at mine. I'm just giving, here's station A, here's station B. It's a hyperbola. The ship is over here. Do you see the ship? The ship is over there. And that's it. That's what it gives us. So it says, assuming the radio signal travels at 980 feet per second. So this is part A. It's telling us that the signal travels at 980 feet per second. Then it says, find the distance between P, which is your point, and A, minus P and B. Okay, so we're going to try to find the distance between, and you're going to subtract it. The thing is, it wants to know the difference, but they told us the difference. The difference in the problem, it says, is 2,640 microseconds of a difference. Do you agree with that? If you look at the problem, it says ship P receives the station of A signal 2,640 microseconds before it receives the signal in B. So we have a difference. But I don't want to know in time. I want to know in distance. So if you know that you have 2,640 microseconds, right? Yeah, microseconds. And then it also told you that it travels 980 feet per microsecond. Then you just change that into distance. And then you know the difference in terms of distance and not time. That's it. I don't know the answer, but someone have a calculator? Are y'all going to be super quiet today? Two 587,200 feet What if I want that in miles? And the only reason I'm saying that is because I'm looking at B, and B says to use miles as the unit of distance. So I'm just going to change it to miles just to be safe. So do you agree that in 1 mile, there are 5,280 feet? So divide that by 5,280. How many miles is that? So 490 miles. That's the difference. I'm not saying that's how far one is. It's the difference between how far they are. So you're going to take how far this is and how far this is, and if you subtract it, you would get 490 miles. Is that okay? Any questions? Okay. Part B is asking us to come up with the equation for this hyperbola. It says finds an equation for the hyperbola indicated in the figure. So that's what I'm going to do. So if I try to find the hyperbola, it's opening up and down. I'm making my center, that's my center, 0, 0, right? If it's opening up and down, do you agree that I'm going to start with y squared over something? I don't know. And then x squared over something equals 1. Does everybody agree that y is going to go first because it's opening up and down? And we're centered at the origin, so we're good to go here. Is everybody okay with that?
Yes,
Any questions? Oh, and my picture is totally wrong. Nobody told me anything. This is A, and this is B. Okay. So based off the picture, this is what we did yesterday. Based off the picture, what do we know? Do we know A? Do we know B? Do we know C? What do we know?
We know A and C.
Well, we know, okay.
Well, yeah.
I know C for sure. What's C?
C is 245.
250?
250, yeah.
250. Is everybody okay that C is 250? Any questions there? Okay, so we're cool with C being 250. So this right here is your foci, one of your foci, right? C is the distance between your foci and your origin. So C is 250. I'm cool with that. And then you're right. We got the length of 2A, right? Because remember, that's going to be constant. So you got the length of your transverse axis. This is 2A. Well, we found out that that is 490. That's what we found out in part A, that it's 490. So then what's A? If you go back to the definition of a hyperbola, I told you that the difference between the foci would equal that transverse axis. That's how they're related. So when you found the difference, that's the length of your transverse axis. So 2A is equal to 490. So then what does A equal?
245.
245. So now that you know C and you know A, could you find me my equation? Yes, no, maybe?
Yes, ma'am.
Didn't you find B? What was the relationship for, I forgot, it was A squared plus B squared equals C squared for a hyperbola, right?
Yes, ma'am.
And you know C and you know A, so you can find B squared. What is 245 squared? Thank you, Jude. So that goes there. I have no idea what B is. 250 squared?
2475.
That's 250 squared? Or you already subtracted? I don't know. I don't know.
Yes,
It's 250.
Yeah, I subtracted that.
Oh, you already did it. You're working faster than I am. Oh, it's 250 squared. What is that? 62500. And then he subtracted, he moved that over. So you got B squared is equal to, you said, what did you say it was?
2475. Yes,
So
ma'am.
that goes here. That's B squared. And there's your equation. You okay with that? Okay. So then part C says, if A is due north of B, okay, and P is due east of A, how far is P from A? Okay. So I already kind of drew it due east, kind of. So we're saying that this is exactly due east is the ship, right? Now, we already know that the distance between the y distance from here to here is 250, right? So we already know that. So your y value is going to be 250. We just don't know what x is. We don't know how far out we went. We don't know this x value. Is that okay? We know that we went from here to here is 250. So you went 250 up. We just don't know how far out we went. But now that you have this equation, can't you substitute the 250 in for y and solve for x? And then solve for x. Let's see. Anybody get anything? I did not get a pretty number. I got a fraction.
For the final answer?
Yeah. Oh, did you not get a fraction?
No, I got 10.1 miles.
Yeah, I got that too. Which is
Okay.
about four. I got x equals 495 over 49, which is approximately 10.1 miles.
Yes, ma'am.
Yeah, that's what I got. We okay? Oh, we're gonna be super quiet today. I'm not gonna know how we're doing. All right. So that is the end of 11.3. So we're gonna do 11.4 now. And with 11.4, insert. It's basically everything that we've learned. So we've already learned all of this. The only difference is that we are going to shift the conic. So it is no longer going to be at a center of 0, 0. If you look at the very top of page 134, it tells you what you're going to do is you're going to replace the x with either x minus h or x plus h. And you're going to replace the y with either y minus k or y plus k, depending on how you're shifting. So what you want to remember, what you want to write down, I'm going to add some notes to this page, is that the center is always going to be h comma k, always. That's the center. Our new center, we're going to say, is h comma k. Okay? That's going to be our new center. So for parabolas, if you're following along in your notes, okay, if you have y minus k squared is equal to 4p x minus h, this parabola is going to open left or right, which you already know because the y is the one that's being squared. So it's going to open left or right. If it's x minus h squared equals 4p y minus k, then this is going to open up or down because your x is being squared. So it's the same as what we had before, except the center is no longer at 0, 0. Okay, so that's like the little note that I would add for parabolas. The next one we're going to talk about is ellipses. If you look at ellipses, if you have x minus h squared plus y minus k squared, this is over a squared over b squared equals 1, then that means that you're stretching, is your ellipse, you're stretching horizontally, right? So that's what it says for the horizontal is the major axis. Here's your major axis. Right under that, y minus k squared over a squared plus x minus h squared over b squared equals 1. You're going to have that vertical stretch. So your major axis is going to be a vertical one. A squared is under the y, so it's going to stretch vertically. Is everybody okay with my notes for parabola and ellipse? Any questions? Okay, moving right along. The next one is hyperbola. If you have x minus h squared over a squared minus y minus k squared over b squared equals 1, that means it's going to open left and right, right? So for the horizontal transverse axis. And then something else that I would add a little note because it really helps me, is that your asymptote is going to be y minus k equals plus or minus b over a times x minus h. So if you go and compare this back to the equations that we had when we did hyperbolas, the only thing that's different is you're adding that minus k and minus h next to the y and x. Okay, and so then if you have y minus k squared over a squared minus x minus h squared over b squared equals 1, then it's going to open up and down, right? And your asymptote is going to be y minus k equals a over b So these are the notes for page 134 that I would have. We okay? Any questions? Ready for a new page? Okay. Okay, so let's go to the first example. So we're on example 1 on page 135. And it says, find the vertex, focus, directrix of the parabola. So we know we're dealing with a parabola, and sketch of the parabola. And what it has is it has y squared equals 16x minus 8. Is everybody okay with that? Now, if you go back, if you come over here and you come back to the parabola, okay, if you come back to the parabola, you have to have x by itself. There can be nothing in front of the x. Do you see that? That x in the parentheses, it's by itself. There's no number in front of it. So using some algebra, in order to get x by itself, I'm going to factor out the 16. So that'll give me y squared equals, I'm going to factor the 16 out. And if I do that, inside of my parentheses, I'm going to have x minus 1/2. Does everybody agree with that? All I did was factor out the 16. Okay, going right back up to parabolas. The y is being squared. The x is by itself. I still want to get what's in front of the x, 4p, 4 times p. So I'm going to come back over here. So I'm going to have y squared equals 4 times p. Wouldn't p also have to be 4? Times x minus 1/2. Now it is in standard form. Any questions? Where'd you get that? How come that's that? Where is that coming from? Everybody cool?
I'm good here.
Okay, so then moving right along. The first thing I want to know is where's the vertex? So the vertex center, kind of the same thing. It's going to be h comma k. So h, here's your h. Your vertex is at 1/2 comma 0. So here's 1/2. That's your h. And there is no k. There's nothing over here with the y. So that's 0. So if I were to come over here and start sketching, 1/2 comma 0, that's my vertex. Can anybody tell me how this is going to open? Up, down, left, right? How's it going to open?
Opens up. Opens down. Oh, left.
It's a parabola, so you only have one, so it's left or right. If you go back to those notes, the notes I just gave you, right? I said if your y is squared, which it is in this case, go back to page 134. If your y is squared, it's going to open left or right. So only one. And then Alec, you're right. You're correct. It's going to open right. And we know it's going to open right because your p is positive, right? So that your p is positive. So it's going to open this way. We okay? Yes, no, maybe? Okay, now this is the part where you need to think. And if you know what how all of these work, it's just about adding and subtracting. So where is your focus? In layman's terms, just talk to me. In a parabola, where is your focus? Anybody? Anybody remember? No.
Are you
Is
asking
it
what?
like
What
where is it? Where would it be located? It's a dot, right? A focus is a dot, a point.
is it? The distance from your vertex to the focus?
Yeah, I know, but where is
Oh,
that? Is it over here? Is my focus over here? Is my focus up here? Where's your focus at? Like where do you draw your focus? On the axis. Yes, in the parabola. Okay, good job. Okay, so do you agree that your focus is here? I don't know where that is, but that's where it is. It's in front of the vertex, right? Your parabola always opens towards the focus. So that's where your focus is. How far is the focus away from the vertex? How far is the focus away from the vertex? Maybe you need to go back to your parabola notes. P. Good job, Jude. Good job. Your focus is P distance away from your vertex. Cool. So I know that my vertex is at 1/2, 0. If your focus is 4 units away from that, where is your focus? What point? Yep. Good job, Jude. 9/2, 0. That is correct. Okay, so same thing. Where is your directrix? Is it your directrix a vertical line that's behind the parabola? Do we agree with that? It's a vertical line that's behind the parabola. So since it's a vertical line, I'll give you a hint. It's x equals, right? X equals is a vertical line. How far is the directrix away from the focus? I mean, from the vertex. How far is the directrix away from the vertex? Anybody? Nope. Y'all are too quiet today. I can't do this. 9/2. Are you saying that's how far it is away, or are you saying that's the answer? I'm confused. Good job, Alec. That is correct. X equals -7/2. We okay? Any questions? Yes, no, maybe? Moving on? Can y'all hear me?
yes, ma'am.
What's wrong? Are we okay? Everybody's okay?
Yeah, I think we're good. I don't know.
Yeah? Okay. Okay. All right, here we go. Next one. Next one is find the center, vertices, and foci of the ellipse. Okay, so for example 2, we have an ellipse now. And they tell us that the formula is x plus 1 squared over 36 plus y plus 1 squared over 64, and that has to equal 1. Does everybody agree that A is 8 and B is 6? Your coordinate plane is way prettier than mine, so make sure that you're using that one. We okay with that? Okay. I don't know what to, literally trying to go as slow as I can. So A is 8 and B is 6. Everybody cool with how we got that? 64 is the bigger number, so that's 8. And then 36 that's 6, the square root, because these are A squared and B squared. Okay, so far so good. Where is the center of this ellipse? Because it's no longer at 0, 0. The center is going to be at -1, -1, because this is +1 and +1. If you remember from section 2.5 college algebra, that it's opposite of what's inside. So if that's x plus 1, then -1, -1 is your center. So if I come over here to -1, -1, here's the center of my ellipse. We agree with that? The next question says, where are your vertices then? Remember, your vertices are the points on the major axis only. So where are the points of your vertices? You should have 2. Where would those be located? Anybody have any answers? I'm a little confused. Those aren't points. Like ordered pairs. Anybody have any answers? I still wouldn't even know how you got that. A is 8 and B is 6. So I don't know where 1 or -1 would come from. Which is good, because I'm trying to, I want to make sure I'm understanding what y'all think it is. What? Okay. That, Georgia, is without transformations. That, it would be correct if the center was 0, 0. But the center is not 0, 0. So where are my new points now? Okay. What? Okay, let's back up. Let's even back up, because I know people are doing their close. Deanna, you're the closest so far. You're the closest so far. Talk to me about what A is. What's A? I know that. I know A is 8. I see A equals 8. I get that. What does it mean in context of the problem? What is A? The first word that should come out of your mouth is distance. The distance from one end of the major axis to the origin. I agree, Alec. So the distance is 8. So if you are at -1, 1, and you go 8 units up, where would you be? This is not pre-cal. This is you counting. If you are at -1, 1, -1, -1, and you go 8 units up, where would you be? Yes, Alec, you would be at -1, 7. That is one vertex, right? What if you went 8 units down? Where would you be now? Yep, good job, Liana. You would be at -1, -9. And those are your vertices. Oh, what A stands for. Like, what does it mean? Then that's what we were trying to do at the origin earlier. If it was the origin, it would be 8 units up and 8 units down. That's true. So it would be 0, 8, 0, -8 if you were at the origin, but you're not anymore. So you're still going to do the same thing. You're still going to go 8 units up and 8 units down, but you have to start at your new center. Does that make sense? Okay, so what are the minor axis points? Let's just have some fun. What are the minor axis points? How far out do I go? Yeah, -7, -1. I'm cool with that. -7, -1, and 5. Yep, 5, -1. Thank you. So here's -7, -1, and then here's 5, -1, and then here would be your ellipse. Yours should be prettier than mine. B is 6. So you're going to go 6 to the left and 6 to the right, and that's how you get these numbers. Are we okay with that? A and B are not points. A and B are distances. Okay, so don't get wrapped up in, oh, that should be a point. It's not a point, it's a distance. It just so happened to be that we were at the origin, so you went up to 0, 8, 0, -8, -6, 0, 6, 0. Like you happened to do that because you were at the origin. Is everybody okay so far? Okay, and then the next thing says, what are your foci? How did we figure out foci again? Anybody want to go back to that note? So for ellipses, wasn't a squared equal to b squared plus c squared? True that, but we have to find c, right? So the relationship is a squared is equal to b squared plus c squared. So a squared would be 64 equals b squared was 36, and that will plus c squared. So then subtract 64 minus 36, what is that, 28? Take the square root, you get c equals, plus or minus 2 to the square root of 7. Again, c is a distance. Do we agree with that? So what does c give you? C is the distance from what? C is the distance from not the origin. Yes, you're right, but That's what it was in A, in 6-1 or whatever we were, 6-2. From the center, right? From the center to the foci. Vertexes for parabolas. So we actually have a center now because we're an ellipse. So from the center to the foci. So even though this is going to be ugly, where are your foci? You have 2 of them. Where are your foci? I think maybe you don't have confidence in it. But you're probably right because you can't add them together. But do you agree that your foci would be located here? Your foci are here and here. So the x value is not going to change, but the y value is. So what you're going to do is the x value is still going to be -1, but the y value is going to be -1 plus 2 the square root of 7. And then this is going to be -1, comma, -1 minus 2 the square root of 7. You're adding and subtracting this distance from your center, but it doesn't come out pretty because one has a square root and one doesn't. So this right here would be your foci. So all you're doing is taking the y value from your center, which is -1, and you're adding your c distance and you're subtracting your c distance to find out where your foci are. Is that okay? I don't have a square root button on here, so I didn't know how to. Okay, I get it. Now that's what I'm saying. You probably just didn't have the. You just do SQRT from now on. Okay, so are we okay so far? Okay, so that's it. That's all of the answers for your ellipse. So keeping this in mind, because ellipses and hyperbolas are not that different. So keeping this in mind, you try example 3. See if what you can come up with for example 3, and then we'll talk. Okay, let's see how far you got. Okay, where's the center?
-1.
-1, -1. Do you agree with that? What's A? Yeah, A is 3. Cool. What's B? Yep, B is 2. If I come over here, the center is at -1, -1. So here's my center. Okay. How is this going to open? It's a hyperbola because there's a minus sign in the middle. Is it going to open up and down, or is it going to open left and right? Maybe looking at those notes on page 134. Is it going to open up left and right, or is it going to open up and down? Right, left and right. Good job. It's going to open up left and right because your X is in front. It's positive. Okay, so it's going to open left and right, so I'm cool with that. So now that you know that it's going to open up left and right, and you know that your A is 3, where are your vertices? -4, -1, 2, -1. Good job, Alec. Yep, that is correct. So here's -1, and you're going to go out this way 3 times. 1, 2, 3. And then 1, 2, 3. Is that okay? So you have -4, -1, and 2, -1. Good job. So those are your vertices. Okay? Remember your foci are in there as well. Here are your foci. So if we're going to try to find our foci, how do you find C? So if you go back to that note for hyperbolas, C squared equals A squared plus B squared. So C squared is going to equal 9 plus 4. Right? So C squared equals 13. So you get C equals plus or minus the square root of 13. So then where are your foci located? Everything, the y value, here's -1. Everything is -1. It's a straight horizontal line. So I know that the y value is going to be -1. That's not changing. -1 for the foci, -1 for the vertices, -1 for the center, right? The thing that's changing are your x values. Your x values are changing. So you're going to take the value from your center, -1, and I am going to subtract the square root of 13. -1, and I'm going to add the square root of 13. You are subtracting and adding your C value from your center to get your foci. We okay? And then last but not least, where are my asymptotes located? So if you go back to the note, I tell you that it's going to be y minus k equals plus or minus b over a x minus h. So in this case, it'll be y plus 1 equals plus or minus 2/3 x plus 1. And this would be your answer. Now, they might make you get it into slope-intercept form, and that's fine. You should know how to do that from college algebra, which means you're just going to get y by itself. So you should be able to do that, but this right here is where you would start. These would be your asymptotes. We okay? Okay, moving right along. Page 136, I give you graphs. So for example 4, I'm giving you a graph, and I want you to come up with the equation of that graph. So check it out, see what you can come up with. Are we okay so far? Does everybody agree that this is a parabola? Does everybody agree that this bad boy opens right? Right? If you go back to page 134, I tell you that if you have a parabola that opens left or right, the formula is going to be y, I'm going to leave that alone for right now, squared equals 4p, and then x, and I'm going to leave that alone for right now. Now, where is the vertex? The vertex is at negative 6, 0. So here's negative 6, 0. So it's going to be opposite when you put it in. So you'll have y minus 0 and then x plus 6. Okay, so just cleaning this up a tad, I have y squared equals 4p times x plus 6. So now all we have to do is find p. What does p equal? What does P stand for? Anybody have P? Testing. Can you hear me? Hello? Okay. 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 P is the distance between your focus and your vertex, right? But we don't know what our focus is. But P is also the distance between your vertex and your directrix, since it's the same distance. They're the same distance away. So if your directrix to your vertex and your vertex to your focus, they're the same distance. So if this is at negative 6 and this is at negative 12, then this distance is 6. Since it's opening up to the right, I know that my P is positive. So I would have y squared equals 4 times 6 times x plus 6. So I get y squared equals 24 times x plus 6. And here is the equation for my parabola. The next one is a hyperbola. The hyperbola is opening left and right. Okay? The hyperbola is opening left and right. So if I go back to my notes on page 134, if it opens left and right, I'm expecting my x to go first. X minus something squared over a squared minus y minus something squared over b squared, and that has to equal 1. If you notice on the picture, here we go. I have a vertex at 2, and it's opening this way. I have a vertex at 6, and it's opening this way. Your center is in between them. So if this is 2 and this is 6, what number's that? It's 4. So if that's 4, then we have the point 4, 0 as my center. So that's H and that's K. So if it's 4, 0, this is going to be minus 4, and this one's going to be minus 0 squared. Okay. A is the distance between your center and your vertex. So if the center and my vertex is A, then A has to equal 2. So this is 4, because that's A squared. Do we agree with that? So far, I have x minus 4 squared over 4 minus y squared over, don't know, I know that's going to be b squared, equals 1. That's all I have so far. Looking at the picture, I see nothing else. They don't give me foci. They don't give me anything else. But I do see some pretty clear points. Do we see some clear points? Right? Don't we see some clear points? Like 0, 4? It definitely looks like that hyperbola is going through the point 0, 4. So couldn't you put 0 in for x, 4 in for y, and solve for b? That makes sense? So you could put 0 in for x, 4 in for y, and then solve for b, because that's the only other piece of information I know. I see some clear points that it's going through. And then you'll know b. I don't know. I didn't do it. That would give me 16 over 4, right? Which gives you 4. Minus, which gives you 16 over b squared equals 1. Where's my calculator? So you would do, move the 4 over, 1 minus 4, divide by -1 to get rid of the negative. So now you have 3, right? So that'll give you 16 over b squared equals 3 over 1. You can cross multiply. You would get 3b squared equals 16. It doesn't come out pretty. And then you just take the square root. Oh no, you could just do b squared equals, because we don't need b, we just need b squared. So b squared equals 16 over 3. So b squared equals 16 over 3. So this is 16 over 3. So then to get a pretty answer, you would have x minus 4 squared over 4. I'm literally going to flip this. I'm multiplying by the reciprocal. So I would get 3y squared over 16 equals 1. This would be my final answer. Okay. All right, I'm going to stop there for today. We will do example 5. I would really like you to try it by yourself and come prepared to talk about example 5. Don't start the next part though. So you should be able to do example 5 on your own, but don't start the next part because I have to lecture on that a little bit. And hopefully we can finish this Monday or Tuesday of next week, and then that's it. And then we'll stop meeting and you'll study for your final exam and you'll be able to take that. Are there any questions or concerns? You do not have a due date this weekend. You don't have a due date this weekend, but that doesn't mean you have nothing to do. I really feel like y'all need practice on this. You need to understand what is A, what is B, what does C tell you? The characteristics of all of these graphs, hyperbolas, ellipses, parabolas. So you really need to get comfortable with that because it's going to get a little bit harder starting on Monday, okay? So y'all have a good weekend, and I will see you Monday.